So for this one, we're going to take it one step at a time. Now, because we cannot, we're going to rewrite it because we cannot simplify this any further. So when we do rewrite it, it stays as root 3 over root 4, or root 3 divided by root 4. Now, the root 3 we can't really simplify any further, but the root 4 we can. And so this simplifies down to the root 3 over 2. Square root of 3 divided by 2. And so for this one, it's kind of, we can do it one of two ways. Now, because it is going to be simplified a little bit, we can kind of take it further, or we can break down each one at a time. So here's what I mean. So if I break down the square root of 27, we can have square root 9 times 3, which is 27, and we can further break down this 9 to 3 and 3. Now, yes, we have 3 3's, but we only need a pair, right? And it doesn't really matter because whichever one we choose, we're going to have that 3 left over. And so I'm going to rewrite this as the square root of 6 divided by 3, which is the 3 that I got from the pair, times the square root of 3. Now, here we can further break this down because we have a square root of 6 and a square root of 3. We can either put those together, or we're going to simplify them, right? So what that would look like would be, we can say 1/3 times 6 over times the square root of 6 over 3, and that simplifies down to 2. Again, we could have done it, kind of kept it as is, so this equals 2, but it's inside the square root, so it's going to stay inside the square root. So this simplifies down to 2, or the square root of 2 over 3. And same for this last one here. We can do it one of two ways. So we can keep it as is, or we can rewrite it as 98 over 32, and then we can kind of simplify here. The biggest number that goes into both of these, well, we can start off safe and say 2, right? So 2 goes into 98. That's at 49 times. And then 2 goes into 32 16 times. And now if we were to break this down, we can take the square root of 49 over the square root of 16, which are both perfect squares. And so the square root of 49 is 7, and the square root of 16 is 4. And so that's my answer for that one, or that's my simplified version of that. So here we have adding, and so we can only add if they have the same number inside the square root. And when we do add, we add the leading coefficient, the number in front of the square root, right? So for this first one, 2 and 5 make 7. The square roots of 3 does not change, so that's kind of where we're at. Same here. Because they have the same square roots, we're able to combine them or subtract them in this case. Now, even though there's some numbers, we pretend there's a 1 there. And so 3 minus 1 gives us 2, and then the square root 2 stays, right? So notice how this first one, initially, they have different square roots, so we cannot combine them, we cannot subtract them. But if we break this 75 down, we have 25 and 3, and then this breaks down to 5 and 5. That 5 comes out, we already had a 3, right? So that 3 came there. We bring it out of 5, and that 3 stays inside. And so here, once again, even though we still cannot combine them, we were able to simplify a little bit further. And so that's 15 square roots of 3 minus 5. Okay, and that's as far as we can take it. Now, if we were to end it up with square root of 5 inside, then we could have taken it a little bit further. But in this case, because they have different numbers inside the square root, that's as far as we can take it.